This video is covering electron energy levels. Really what we're going to be talking about is just looking at where our electrons have the potential to be on the atom. So earlier in this chapter we've established that we have things called protons, neutrons, and electrons. In the last half of this chapter, we're very focused on where the electrons are and what they're doing, because it's the electrons that actually do the chemistry. So in section 6, we're going to talk about the possibilities or the places that electrons can live. In the next section, we'll actually talk about where electrons live on specific atoms. And then at the end of chapter 3 and moving into chapter 5, we'll start talking about how those electrons actually interact to do the chemistry that they do. Okay, so we're just building upon concepts. So earlier in this chapter we talked about Rutherford's atom. That was one of our history lessons. And his method or his theory on the atom is essentially what we're working with, what we want to keep in mind. So we have our tiny, dense, positively charged nucleus with the protons in there, and then we have our electrons surrounding them. Through quantum mechanics, so basically it's intense, crazy math, definitely math we're not going to discuss in this course, but just know that there is math and concepts to back up what we're talking about. But we get from quantum mechanics 3 ways of kind of describing where these electrons are. So we talk about their energy level, their shape, and their orientation. The energy level is also known as the quantum level, hence quantum mechanics. And this is just kind of a fancy way of saying how far away from the nucleus the electron is. The symbol that we give the energy level is the lowercase n. And what it tells us is that the higher the n value, the further away from the nucleus that electron is. So an example of this, we're going to talk about shapes in 3 dimensions, but we do have the first shape that we'll talk about is an s orbital, and it's spherical in shape. So if this was the 1s level, the n value, that symbol there, the n number, the value is that number out in front. So that's the number out in front. If we were to draw a 2s orbital, our electrons have to be further away from the nucleus, so we would have a bigger sphere. And 3s, we'd have an even bigger sphere. Okay, so the larger that number out in front is, essentially the larger the shape. Now this is very basic introduction to electron energy. There's a lot more going on here, but for what we need to discuss in this class, that's the level of understanding that we need to be at. So don't want to push our expansion too far. We want to keep it simple so that we can make sure our discussion stays consistent. All right, so we have our different sized orbitals, our energy levels. Bigger number means bigger size. Then, so that's one of our describing characteristics. Our second one and our third one we kind of consider together. We have the shape of the orbital. And then we have which orbital, which is essentially 3D orientation. How many ways can we rotate that orbital in space? So our shape, we have 4 different ones. We have an s orbital, which is this one here. It's the sphere shape. So we represent that usually just with a circle. And I have pictures of them at the bottom of the page, but this is your s orbital. We have the p orbitals, which are dumbbell shaped. So I draw it like a figure 8 or the infinity symbol, if you know what that is. We'll just do orientation at the same time. There's only one orientation, one way to rotate a sphere in space. So the 3D orientation of our sphere is there's just one orientation. For our dumbbell shape, our p orbitals, and these are p orbitals. There's little subscript numbers next to this P. Don't worry about those. Those are well beyond the scope of this class, so you can just ignore them. But you'll notice we have 3 of these shapes. Okay? One's along the x-axis, one's along the z-axis, and one's along the y. So we have 3 different orientations of the p orbital. And although I'm using this word orientations, you can just kind of think of this as orbital. So that might simplify our discussion here. So we have 3 different p orbitals that we can work with. For every n value, they have the potential of having these different shapes. That isn't always true, but for our discussion, we'll be okay with that. So there's our second orbital. We have our third orbital is a D, and that's a double dumbbell. So we have one dumbbell, a second dumbbell, kind of looks like a fan. There are 4 different orientations of the double dumbbell. Then we have a 5th orientation that's going to be a dumbbell with a donut. So we'll have a dumbbell with a donut around it. So for a better drawing of that, we have a computer generation here. These are the D-Orbitals. So it's kind of color-coded. It's a little difficult to see, but we have one lobe, one P kind of shaped dumbbell there going along the y-axis in this case. Then we have a second one going perpendicular to that, so on the x-axis. And how these are shaped and aligned on the axes, don't worry about that. Just the overall general shape is what we're interested in. This one in the center is the funky dumbbell with the donut. So we have a dumbbell, and then we have this donut portion going around. So we have 4 double dumbbells and then 1 orientation of the dumbbell with the donut. So total, we essentially have 5 orbitals that are D-shaped. Okay, so there's 4 of those, 1 of those to contribute to our 5. Our 4th shape is an F orbital. These ones get a little complicated. Most of them are a double D orbital or a double dumbbell. Okay, that's a mouthful. It's just easier to see the picture rather than to try and describe them or draw them. And these ones down here are the F orbitals. Okay, you'll kind of see there's 8 total lobes here. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so essentially double this up, you'll get something like that. And then we get the funky dumbbell with the double donut. Okay, down here, so we have a dumbbell shaped and then the double donut around there. Doesn't really matter. I'm not going to ask you anything about the shape of an F orbital because they're just too complicated to draw and make them look good and appropriate. So we just call them complicated. Okay. But we do need to know how many there are. So there are 1, 2, 3, 4, 5, 6, 7 orientations. So we have 7 F orbitals. For reasons we are not going to discuss, if you go on in chemistry, you'll discuss them further. For us, you just need to take me at my word, and that 2 electrons live per orbital. So what that means is in any 1n level, okay, n's can have these potential shapes. Not all of them can have all these shapes, but these are possible. We have the sphere, 1 orbital, so it can only hold 2 electrons. In the dumbbell shape, we have 3 orbitals that can have that shape. So 3 orbitals times 2 is 6 electrons. These two together hold 8 total electrons, 2 plus 6, and that will come up a lot at the end of this chapter and in chapter 5 that we're wanting to achieve this 8 total electrons. We call that an octet. More about that later. We have 5 orbitals that are of the D shape, so either the double dumbbell or the dumbbell with a donut. 5 orbitals, 2 electrons each. We can have 10 electrons in the D orbitals. 7 orbitals for the F shape, so we have 14 electrons can be in the F orbitals.